Large language models, LLMs, despite their advanced designs and impressive benchmark scores, are surprisingly vulnerable to simple tricks like run-on sentences, poor grammar, and image manipulation. This revelation challenges the optimistic narrative that artificial general intelligence, AGI, is just around the corner and exposes just how naive these models remain in ways a human with common sense would never be fooled. But here's where it gets controversial. Researchers have recently uncovered several glaring vulnerabilities that show even the most rigorously trained LLMs can be easily misled in ways that bypass their safety layers. For instance, as these sentences drag on without punctuation, the model's built-in rules that usually block harmful or sensitive content simply lose track and give up. Additionally, LLMs fall prey to hidden tricks embedded in images. Some images contain secret messages invisible to the human eye, but detectable by the model when the images are resized or processed differently. This flaw opens the door to covert attacks where dangerous commands slip past unnoticed. David Shipley of Beauceron Security paints a vivid picture. Prompt security around LLMs is like a poorly built fence. LLMs are typically trained using a method that encourages them to refuse harmful requests by adjusting the probabilities, logits, of certain words in their responses. Ideally, when faced with dangerous prompts, the model should refuse to comply. However, this training doesn't fully close the door. It only lowers the chance of a harmful response. Attackers can find ways to narrow this gap, effectively pushing the model toward giving dangerous answers. The secret weapon here is bad grammar and run-on sentences. Researchers from Palo Alto Network's Unit 42 found that if you never let your prompt end with a proper punctuation mark, the model's safety system has much less opportunity to regain control. Astonishingly, they achieved success rates between 80% and 100% with just a single prompt, requiring almost no special tweaking across major models, including Google's Gemma, Meta's Llama, and Qwen. Even OpenAI's latest open-source model, GPT-OS20B, fell victim with a 75% success rate. This starkly shows that relying purely on internal safety mechanisms is far from enough. Determined adversaries can and do walk right through these defenses. Now, imagine this issue in a real-world setting. Enterprise users regularly upload images to LLMs, unaware that these images might contain harmful hidden commands. Trail of Bits researchers demonstrated that by embedding instructions visible only when images are scaled down, a process models often perform, the AI can be tricked into leaking sensitive data. For example, images that appear uniformly dark, at full size, suddenly reveal red-tinted hidden messages when resized smaller. These hidden commands directed Google's Gemini CLI to retrieve calendar appointments and send that information to an email address. Actions the model executed blindly. Such attacks aren't one-off tricks. They require tailoring based on how each model rescales images, but have been successfully demonstrated against a range of powerful tools, including Google Gemini CLI, Vertex AI Studio, Google Assistant, and Genspark. The worrying part? Similar vulnerabilities likely exist in many other systems too. Hiding malicious content inside images is no new tactic. It's been known for over a decade and is both foreseeable and preventable. Still, Shipley argues this exploit reveals a broader truth. AI security is often slapped on as an afterthought rather than engineered from the ground up. The recent Google CLI vulnerabilities are just the tip of the iceberg. Another security firm, Tracebit, found that prompt injection, flawed validation, and poor user experience design combine dangerously to allow malicious commands to slip through unnoticed, making the threat both significant and stealthy. Why are these glaring security gaps still so common? Valence Howden from Infotech Research Group explains that it boils down to a fundamental misunderstanding of AI's intricacies. You cannot set up effective security controls if you don't fully grasp what AI models do internally or how they interpret prompts. Traditional static security solutions simply cannot keep pace with AI's dynamic and ever-changing nature. Adding to this complexity is the fact that about 90% of these models are trained primarily in English. When other languages come into play, the subtle context clues that might flag security issues vanish. Howden emphasizes that current security frameworks aren't designed to police natural language as a potential attack vector, meaning AI demands an entirely new and yet-to-be-developed security approach. Shipley goes further, insisting the root cause is that security was an afterthought from the start. Many publicly available AI models suffer from what he calls the worst of all security worlds: insecure design coupled with clunky security controls. Even more alarming is that these models often embed social engineering, the most effective attack technique, right into their core. He uses an evocative metaphor to describe today's LLMs. Imagine a huge urban garbage mountain turned into a ski hill. You can cover it with snow and ski on it, but every so often, a terrible smell from the trash beneath wafts up. In other words, these models are built on messy, unvetted datasets filled with problematic content, with cleanup being the almost impossible, albeit necessary task. We are essentially playing with a loaded gun, Shipley warns, and the recent security breaches are just the scattered shots, some bound to hit and cause real harm. So here's the question. Are we doing enough to secure AI systems before widespread adoption brings real-world consequences? Or are we blindly trusting technology that's still riddled with critical flaws? Share your thoughts and concerns. Do you believe these vulnerabilities spell doom? Or can the AI industry catch up quickly enough? The debate is wide open, and your voice matters.